So today we're going to talk a little bit about trends on the periodic table, and really the periodic table is just a trend put on paper. That's how they built the periodic table. They found the trends, and then when they arranged the trends, the periodic table sort of fell into place. It became a thing because of the trends that they were able to arrange. Now, we put the periodic table according to atomic number, and they tried to do it for a long time according to atomic mass, and when they did that, there were a couple of hiccups, and it really confounded people for a long time. But when they were starting to work on the periodic table, they didn't really know a whole lot about the actual mass or structure of the atom. That all came kind of later. There were people making periodic tables back in the 1800s, and the experiment that we did with the Rutherford experiment that actually figured out that the nucleus is very small and very dense. That happened much later. The neutron, that really kind of defined the mass of the nucleus, because before that they thought everything was like a half positive charge. Could you imagine how confusing that would be? The neutron wasn't discovered until I'm thinking 1930s. So that's just a long way to say that the periodic table is made up according to trends. Now, some of the trends that we really have to know about is the fact that as you go from left to right across the periodic table, left here, right being here, there's your noble gas, there's your alkali metal. So as you go from alkali metal to noble gas across a row, this is the biggest element in the row. And the reason being is as you go across a row, every time they add one proton. And that proton squeezes in the electrons just a little bit. And so you're like, but Mr. Burr, they're adding electrons as well. They are, but they're adding electrons in the same energy level. So this is adding in the 3 energy level, which is roughly the same region from the nucleus. And so that's not really making anything bigger because it's all in the same spot. So since this is adding, sodium adds 3s1, and since it adds that in the 3rd energy level and it has the least protons, it holds that electron the least, and we see that in sodium's behavior. It is very, very quick to lose an electron. And then as you go across, you add one more proton, and again, it just kind of hugs it in a little bit more. And then when you go down, down a column, they get bigger because every time you go down the column, you're adding a whole other region to the electron cloud. So if we look at the first column, you've got 1s1, 2s1, 3s1, 4s1, 5s1, 6s1, 7s1. And it just gets bigger as you go down. So the periodic trends that we have discussed here are that atoms get bigger as you go right to left and top to bottom, which, if you remember this, francium is generally considered to be the biggest, baddest boy on the periodic table. And you're like, but Mr. Burr, what about these guys? They'd fit in right here, and francium is still on the bottom and in that corner. So this one, shout out Anna Wampler for asking this question. So I think we Wampler.